All right, an official good evening or good morning, good afternoon, as discussed to everybody. And welcome back to the second week of our DevOps short course presented by Brenton Birchmore. My name is Jack. I'm a course consultant and eligibility and assessment officer at IT Masters and Charles Sturt University, joined by Brenton Birchmore, who is one of our wonderful subject mentors and also subject authors, as well as a host of other fantastic qualifications in and around the IT industry over a number of years, who was presenting with us last week, and Kit, who is going to be helping us out with tech support and the back end of running the Zoom room this evening. So just before we get the subject topic started, it would be really fantastic if everyone would like to, once again, feel free to navigate to the chat section on your Zoom, set your to who you're talking to everyone so that everybody is able to see your messages. And we would love to know if anyone has something, what was, I suppose the question is, what is the thing that stood out to you most from your experience with us last week? If you were here last week with us, same time, same place, your computer, what were the topics or what was your takeaway from the course that came through the strongest? Always good to have a little bit of a refresh of the brain to what we were talking about this time last week. So feel free to drop that in the chat. A little bit of housekeeping as well. If you have questions for Brenton that are about the technical aspects, about the actual subject matter and topic material of the course, feel free, and you would like those questions answered, feel free to put those in the Q&A section to ask questions that can be answered in our little Q&As sort of between slides and at the end of the session as well. If you've got questions more about the administrative side of things, questions about IT Masters generally or CSU, and how the webinar is run, that sort of thing, please direct those to the chat section. And also please feel free to use the chat section to interact with your other attendees. There are a lot of people in this course with a lot of their own knowledge as well about the topic and similar topics. And it's always great. There's always some really great insights that are dropped into the chat from our participants. So that's a fantastic resource. Feel free, if you've got comments that you would like to make, to put those in the chat as well. So we will get underway just very shortly. Before we do, my name's Jack, as I said, and I'd just like to acknowledge before we begin that we are broadcasting this evening from the traditional lands of the Wurundjeri people of the Kulin Nation in what's currently known as Melbourne, Australia, and pay respects to their elders and ancestors, acknowledging their ongoing connection to land, waters, and culture, and their sovereignty, which has never been ceded. So, without further ado, once again, feel free to put your comments and insights in the chat, questions for Brenton about the technical aspects of the presentation in the Q&A section. We'll do our best to answer as many questions as we can throughout the course of the evening, or the webinar, I should say. And let's move on to topic number 2 of our DevOps short course, continuous delivery. Take it away, Brenton.
Hello, thank you, Jack. Hello, folks. Good evening, good morning, good afternoon. Welcome back for another round of what we're going to cover in DevOps. We're going to go to a slightly more detailed discussion tonight and hopefully pick apart a few more specific details of a little bit of how-to. Not too much, not too detailed, not too technical, but hopefully something a little bit more practical. I had a quick look as Jack asked everyone, what was your takeaway from last week? And I did have a quick peek at some of the chat that was scrolling through, and I saw that contiguous knowledge popped up there quite a few times, which is great to see, because what we were hoping to do last week is shape some of the raw concepts, some of the underpinning ideas, things that to some extent might shake the foundations that we've previously been sitting on, so that we can have a fresh or different view of what might be possible. We're going to do a little bit of that tonight because I want to show a connection between what the terminology within DevOps is of continuous delivery and relate that back to the more foundational concept of flow. And we'll talk a bit about where that starts. We'll rehash on some of the things we talked about specifically with Kanban, and then we'll start to look at practicalities of how do we actually do that. So just refreshing the course syllabus, the things that we're going to go through over the 4 weeks. We've already done step 1. This week, we're going to talk about continuous delivery. We're going to talk about flow, and we're going to talk about how to do that within a DevOps environment, or at least the things that DevOps tries to get us to do and why it does it, which is perhaps at times the more important part of the question. So what we're going to talk about today, we will have a brief introduction, reminder, I guess, of Kanban and what it represents, because it was a precursor. It was original ideas that led to the sorts of things that DevOps has now adopted. We're going to talk about alignment, specifically about the alignment of environments. What does it mean to have an aligned environment between operations and development? Why is it important, and what does it matter? We'll talk about automated testing, the importance, the relevance, what does it really mean? We'll talk about continuous integration. This is one of the really big cornerstones that is quite different to how teams perhaps operate without the DevOps mindset. So when we go through this, if you start to see things that are familiar and say, yeah, we kind of do that, then you've already crossed some major bridges in the direction of DevOps, if that's the case. And lastly, we'll talk about how deployment patterns and reshaping the way in which we define and understand the deployment of code and software might make it a bit easier for us to do what we do on a continuous delivery basis. So this is our journey tonight for the next hour or so. We will pause for questions at some point along the way. So don't forget, if you have any questions about what we're talking about, throw them in the questions box and we'll find a suitable time to pause and have a bit of a chat about those. Now let's start with an attempt at a broad basic description of what I'm talking about when I talk about flow. We talked last week about value streams. We have touched on the idea that all of what DevOps is about is part of the bigger concept of a value stream. And flow is about continuous delivery, continuous activity, but just enough, optimized efficiency. We're not overdoing, we're not over preparing, we're not over organizing, but we are doing things close together. And you did point out, as many of you pointed out, the use of the word contiguous when I talked about contiguous knowledge. And it's unfortunately similar to the word continuous, which gets used a lot as well. But the contiguous idea is one of the cornerstones. And how contiguous activities, activities that are lined up next to each other, and why that matters is an important part of how flow works in a DevOps environment. So let's have a reminder about what we looked at last week. This is the same slide from last week that specifically talked about how Kanban has influenced the DevOps paradigm. So there was the idea of flow, where things are meant to happen just in time, just enough, just what you need, and only at the right time for it to be beneficial. There's also visibility, the fact that things aren't hidden. You don't have tasks and activities hidden away in different to-do lists. They're visible, they're exposed, they're things that the entire team has some visibility to, because in DevOps, there are reasons, which we'll talk about shortly, where the entire team might have a role to play. We want to make sure that we're only doing what we can get done within the way we're trying to do it. So within the DevOps, borrowed from Kanban, is the idea that you don't code more than what you can test within a reasonable time frame, nor more than what you can integrate. So we don't do these large amounts of code writing and then this large amount of testing of it over a period of time. And then we get this big spaghetti of code and changes that we're trying to integrate later as, you know, a big mess that's just fallen out of a washing machine. What we're trying to do is one piece at a time, one article at a time, enough to get certain things done within a day. So that's the limitation of work in progress idea. Also, the constant improvement. This is something that also came out of Lean, part of the agile paradigm. It is a big part of DevOps. Because things happen in small bite-sized chunks, there's an enormous opportunity for a bit of a retrospective perspective. We can look back and say, well, how did we do that? How did we do that yesterday? Because we did a bit of everything yesterday. And what happened yesterday that made it hard And what might we do today that will make that easier? And that's how fast we can improve what goes on in a DevOps environment, like literally the next day. And that's how it should be. And that's the most effective way to implement improvements. And so the opportunity is there. So the impetus should be as well. The other idea is pulling activities in where people have ownership. People can pull something in. It's the idea of self-service within the DevOps environment. If one member of one of the teams needs something, then ideally, as much as possible, systems should be in place and preferably automated to let them pull that information, pull that result, pull that activity, pull that task into their queue, let them use it, let them work on it, let them take advantage of it. Now, these ideas aren't expressed in the same way in the DevOps paradigm. They are talked about a little bit differently. And we're going to talk about them now from the point of view of the practical things that tend to happen in a DevOps environment. But this is where these concepts came from. Now, I have got a poll, and I'm sure Jack has got this poll that she's already put in for us. The poll is, what do you think out of the options that we've got here that are common reasons why code deployments don't go very well? Jack, are you able to help throw that poll up for us?
I am. I've just thrown that up, or I've put it up to say that in a better way.
Phrase. I do make that mistake
it up to
often.
be very Australian about it. Actually, that also sounds
tossed.
bad. Please forget I said anything. The poll is available to you. Please, you can select as many options as are applicable for you.
Now, if there's a glaring omission there, something that you wholeheartedly believe is a core reason or a better way to put it, then by all means, put it in the chat and tell us there what you think it is. And or tell the crowd. You might get a few people agreeing with you there. This is obviously not meant to be an exhaustive and complete list, but hopefully it gives many of you an opportunity to share an idea and think about what do you think the problems tend to come from? And we're going to talk, as we go through the next few slides and discussion points, hopefully find a few things out of DevOps that tries to address some of these challenges, some of these problems, and push back on some of them.
So I'll leave that up for about another minute and a half, I would say.
Okay.
So the number of people, or would you like the answers as they go? Alternatively, I suppose slide. I could commentate the poll results coming in like a horse race, but I don't know that that's everybody's ideal outcome.
Well, everyone can see there. We can. Are we slowing down? I think we're slowing down. Yeah. We might end and share that, mainly because what we're about to cover next is positioning at least some of those answers.
Yes. Okay. All right. Well, 10, 9, 8, etc. I'm about to close the poll. Please vote if you have not yet.
Close your eyes and click if you're not sure.
Okay. End poll. I've done it. All right. So the results are in. We've got 65% of people have said that external time pressures on both dev and ops teams to deploy code before it's ready is the most common reason that code deployments do not work well when launched.
That's big.
65%. I mean, it is, people are able to select multiple options, so people could have select several. 44% have said that the dev team lacks a complete, accurate, and current testing environment to test in. Then we've got 38% on ops struggles to find the time or resources to fully support dev testing and QA. Then we are down to 29%. The dev team lacks the time, skills, resources, or other assets to deliver reliable code. 23%, ops lacks the chance to fully prepare production for code updates. 17% say we don't, we've got 29. Oh no, we did do that. Sorry. And yes, 17% say we don't have a clear idea of exactly how production is fully configured anyway. So those are the results. Would anyone, if it has not yet been entered into the chat, if anyone would like to do so before I stop sharing in the next 5 minutes or so, feel free. But I'll leave those up for Brenton to keep talking about the results and about following on from that.
Excellent. Thank you, Jack. I found that quite interesting, the number of people that have pointed to external pressures. And I'm going to come back to that. I'm going to leave my window open, and I might even reshare that poll later on when we start to talk about some of the remedies for some of this, so that we can remind ourselves of the sorts of things we shared that you guys talked about, and hopefully pinpoint what some of the aspects of DevOps can actually help with. But I want to start with one in particular, and that is the Great Disparity. And this is the starting point where DevOps says, look, before you can be clever about anything else, you absolutely need to have an identical test environment that's the same as production. The Great Disparity is that if there's a difference between the test environment and the production environment, you are absolutely going to have problems. And it's not a maybe, it's not a what if, it's like, well, how bad are they going to be? There's going to be something. And when the operations team, which often traditionally and typically, well, they own the production environment, that is their core responsibility. And so it's often the operations team that are required to be creating test environments, because it's coming from a production environment, and being able to produce facsimiles of that, test environments, copies, and making them exactly right and exactly up to date. That's their job. But that's helping testing. Now, there's often a competing priority, because ops is dealing with other things, other pressures, other demands on their time. And putting out another version of the test environment for the developers to test on isn't necessarily at the top of their list. Not only that, production environments evolve. And a brave 17% of the contributors said that we don't even know exactly what our prod environment actually works like at the moment. There's something we don't know. And I would suggest that, that probably the number of companies that are at least somewhat in that situation is quite a bit higher. But it's a battle, because there's constantly something changing. So this is something that DevOps has a pretty ironclad opinion about. The alignment idea says that when you're working in a development environment, the test environment you have must be an identical copy to live production. It must be exactly the same. It must also be the current production version. Now, it's not always like that. And for many of you, you're immediately aware of the reasons why that's not easy, the reasons why that's hard. And many of those reasons start off as a resource issue, but they actually come down to a technology issue or a methodology issue. There are ways within every kind of technology that you've got to create systems that make it easier to create another image, to create another virtual machine, or something that will give you a copy of what's in production. But it needs to be available quickly. So when developers are working on something, they're working on a piece of code that under DevOps, they need to integrate with the main master program this afternoon. They're building it this morning, a little bit of code, and they want it to work in the master program this afternoon. They need a copy of the master program today. And if it changed from yesterday, they need a new copy today to work in. Now, they may be working in it, and they've got some problems, and they've made some experimental changes in their version of the test environment, and those changes didn't work. They thought they could figure out how to integrate their bit of code by changing something else, and it didn't work, so they've got to wipe their version of the test environment and build another one in the next 20 minutes. That's what we want to be able to do. This brings the self-service idea from DevOps into the possibility of saying devs need systems, not people, not resources, but systems that will allow them to pull into their environment a new copy of the current live production system. Doesn't mean they tamper with the production system. Doesn't mean they touch it at all. It means that as an automated method, when production is doing anything, they are constantly shaving off copies in such a way the dev could just duplicate them to their heart's content at any moment of the day. So that there is never a situation where a developer is going to be hamstrung by not having an accurate visibility of what's currently in production right now. And actually, it doesn't really matter if you don't have everything documented, if you don't know what every bit of configuration is, if there has been some ad hoc stuff going on. If that's going to create a hurdle for a developer with a particular piece of code, let them find it when they run their tests in their test environment, which is an echo of the production. And then they'll see that, hey, this has happened. Oh, we didn't even know that bit of code was in there from last time. Well, now we do. And we found it because the developers had the opportunity to use the exact copy of what's running right now live. So that's one of the very crucial starting points that DevOps says that we need to be able to do this. This is part of the idea of minimizing wastage, because from a DevOps point of view, anything that's inferior, out of date, inaccurate about the DevOps testing environment is an absolute waste of the developer's time. 100% waste in many cases of the developer's time. And we want to get rid of all waste. Well, we're going to start with getting rid of the most obvious waste. And now, another question that comes up is, well, hang on, that's costly, that's money, that's investment. Well, yes, but wasting developers' time is also an investment, because we're not just wasting a developer's time. What we're wasting is all the time that gets spent on fixing that problem when it gets discovered, when something gets launched in the production environment and the gotcha happens. There's wastage there as well. So we've got to start with having a correct environment where the production environment, the testing environment are in absolute alignment. So this, as I mentioned, triggers the conversation about automation. Automation has a number of important uses. We already know this. This isn't going to be a new idea for everybody, but it's a reminder of what are the various benefits of investing in some sort of automation to do many of the things that we're going to need to do in the DevOps environment. Of course, it's a time saving. And of course, having things automated improves our ability to get more done. It means that things that are repeatable or repetitive, like pulling a copy onto individual workstations for individual developers on a daily basis, we can automate that. We can avoid human error from manually handling certain things. We can provide a large amount of testing, for example, that creates a large amount of outputs for analysis. We can look at trends. We can run simulations hundreds or thousands of times with automation. And it means we can do that exactly when we need to, which is the flow idea. We can allow developers to say, I want to see what happens if I run this piece of code with these 1,000 different variable inputs. Let's do a Monte Carlo simulation and see what kind of results we get out of it. We could do that now. So this is where we start to talk about automation, not just from the point of view of, okay, let's make it something that'll let us replicate an environment. What about testing as well? Now I'm back to the word contiguous, because I'm back to talking about lining things up adjacent to each other. And DevOps, let's say we've got the environment sorted out. We're now dealing with testing and the mentality behind testing. So DevOps has the idea that contiguous testing means that you build a bit, you test it. You build a bit, you test it. You build a bit, you test it. So this means that every bit of code that we create, because we're testing it in such close proximity to when it was created, we can maximize the benefits of cognitive flow. We know what we just coded a couple of hours ago. And if we've just done some code and we're running it through some automated testing over lunchtime, and we're coming back after lunch to see what the results are, our head is in exactly the right place to then start diagnosing, troubleshooting, and fixing whatever went wrong with that code. But if we spend all day writing code and a couple of days writing code, then we come back next week with some testing that's come from someone else, with some answers to say, here's the bug report from your code from last week. Hard to get our head around exactly what it was that we were doing when those problems came into it. So again, it's the lean approach. It's the minimizing waste. It is just quicker in terms of time and effort, processing time of a developer to fix the code right then and there. So testing needs to be as contiguous as we can reasonably make it. And therefore, because it's difficult in times to get testing people to be totally lined up with the development and the development people, that's where automated testing for some things, where possible, creates a bridge, a stepping stone to give some feedback to developers to say, okay, here is a way that you can test certain pieces of code, certain activities, certain functions. Now, there's other ways in which contiguous testing comes about. There's different ways, different paradigms that have been thought about. There's partnering, where developers and testers work side by side. There is test-driven development, which is the idea that if you've got developers that have access to testing automation systems, then whilst they're thinking about writing the code, they're also thinking about how do they script and write their testing processes. How do they write their test scripts? What do they need to have and write and do? They're in control of the automated testing environment. And they can wipe it and pull another copy if they need to, but they're the ones that are empowered to say, I'm going to run these tests. And so therefore, they have the opportunity to do test-driven development, where everything that they create is created with its test in mind at the point where it's created, because that testing is happening in a few hours. So automated testing helps lean into that. Pair programming is a way where, at the very least, even though you're not necessarily having two people, one person testing, you have two people where two heads are looking at the same problem, and you might have a better chance of uncovering obstacles. But these are all just the different ways in which the idea of contiguous testing can be feasible. Let's refresh on some of the testing or types of testing that goes on in the software environment. You have unit testing, which is where you're testing small individual pieces of functionality, just a little bit of code, a little bit of this, a little bit of that. You have integration testing, where you're testing how multiple types of code and things happen that come together, and they need to work correctly together with the main software. So that's a level of integration testing. And then you get functionality testing, which is where you're testing it more from a human perspective. You're testing a little bit more about, if I do this, this, and this, do I get this? So often you need a more contextual, a more human perspective on whether or not this is meeting the requirements of things like user stories or expectations. Now, if you're trying to automate any of this, typically the unit testing stuff is the easiest. That's the stuff that is not too difficult to write a testing script for, run it through some automation, and the developer gets some quick early access to some useful information that helps them refine their code. It is harder, but still feasible, to create automated testing for integration. Why? Because we have a never-ending supply of the exact copy of the production environment on this machine right here next to me or in front of me. So I have an endless access to the exact versions of what's going on in production. I can test my stuff in the production version anytime I want for as long as I want. And I can run all sorts of automated testing and say, what did I break with my code? It is harder, perhaps difficult at times, to create full functional testing. That requires more detailed, more complex testing scripts and algorithms, but it's not impossible. And larger organizations who have the budget certainly do and can invest in those sorts of things.
Speaking of the budget, I have seen a few mentions in the chat just passing through, talking about how testing and budget are nearly synonymous a lot of the time. And I do have a quick question before you go further into automated testing. Let me know if this is going to be covered. But I would assume, tell me if I'm wrong, that the time frames for which kinds of tests you're running and when are fairly determined by the type of testing that you're running, and as well as obviously the budget and the resources and things. But each of these are going to be run on what kind of a time frame would you estimate for each of them, or would you say is usual?
If you look at a scale, you can often get multiple results of unit testing in a matter of minutes, because you're testing fairly small things. So you can run a simulation of 100 times of something and get a report out of that in a time frame measured in minutes. If you're doing integration testing, what changes is the number of outputs that you need to examine. And it's the analysis of the testing that usually takes the time. You can just run 100 inputs and 100 stimuli in a pretty short period of time in most cases. The time is when you are looking at you're looking for the indicator that something went wrong. You're looking for the anomalies. You're looking for the outliers that have been triggered. That's the hard part. And actually, functional testing is not necessarily harder from a complexity point of view, because usually the problem with functional testing is that you do need some sort of increased human contextual input, because you need the user story perspective that says, I'm supposed to get this report appear. Did I get that? Is that report going to tell me what I need to know? Because that's what this code's meant to give me. And someone who can evaluate that needs to look at that report and say, yeah, that gives me what I need, or not, as the case may be. So that's where functional testing has that extra layer of difficulty, especially when you're talking about automating. So in terms of time frame, minutes for unit testing to easily spot anomalies in the data. It can take more than that, but you don't want to be doing integration testing on anything that's going to take you more than maybe a couple of hours to go through a thorough examination of the results. Because if it does take you much longer than that, then you might be working on something that's too big. And if you are, because it has to be big, then maybe that's a small team effort. Maybe that's 2, 3, 4 people working together, where you've got people doing core coding and you've got people that are running the simulations over and over and reporting back and saying, okay, this is what's happened. This is what I found. This is where the integration didn't work out. But I do want to address the point that you raised, and a lot of people are raising, about budgeting. Now, there's a paradigm here that says that when all of these issues, and we've only just sort of started to dig into these now because we've got another couple of weeks to talk about more of it. But when we get all these working very well, what changes dramatically is lead times. And when I say dramatically, I mean as an order of magnitude. What if a team could put out twice as much code, 100% increase in productivity and output and chargeable value? What would that do to their ability to say, okay, we need some more funding. To do that, we need some investment in automation. We need some investment in tools. We need some investment in this and that. So it's not about, okay, how can we just do things 10% better? It's how can we do it 100% better? And that drastically changes the discussion about funding, resources, and budget. So DevOps is not about tiny little changes. DevOps is about drastic improvement to the rate and speed of delivery. And let's say you want to, let's say you need to double or triple the rate at which you get things delivered. Well, DevOps is your only current answer. And then you look at the history of organizations that have gone down this path. And the book that I've suggested people have a look at has a number of case studies in it. And in there's lots of discussions about large organizations that said that we went from doing something once every 8 weeks to doing every single day. And when you can get that kind of effectiveness and productivity, then it becomes a lot easier to actually invest in that because the value is clear. But it's a bit of a chicken and egg problem, right? Because if not everyone is convinced that this is going to work, then it's hard to get the money before you get the results. But that's where the maturity of DevOps having come about already is an advantage. Now, I notice we've got a few questions. I think, Jack, after this next slide, before I get into the next part of our discussion, we might pause and see what questions we can answer in just a moment.
That sounds perfect. Let's do it.
All right. So a final couple of points on automated testing. They give you immediate results. To developers, you can write some code, write some testing scripts to go along with that, plug that into your testing paradigm, get some immediate feedback, perhaps within moments, go back to your code, make some changes. That feedback loop is incredibly tight, and that is incredibly useful. You could also do a much larger volume of testing compared to what you might do if you had human-based testing. Automated testing lets you say, run these inputs 1,000 times. It's not going to be easy for a person to go through a process 1,000 times in a piece of software, but an automated system can do that. It also means that you get more and more synergies when you get to the deployment stage, because test-based development means that the developing process is constantly thinking about success at the deployment stage. It's constantly thinking about quality assurance because it's baked in to the development mindset, to the development process. Because they're fully empowered, they're also fully responsible for their piece of what they can do. And automation is by far the best way to do that. And so you get development much more able and much more effective at doing a first layer of quality assurance so that what they're producing is of higher quality all the time. Not only is it quicker, it's consistently higher quality. Let's have a chat about the questions. Jack, what have we got that we can tackle for a few people?
Well, I think very related to the automated testing, we've got a couple of questions on a similar topic. So Eduardo has asked, making copies of production system brings the problem of data coming with it, which in most cases should be a no-no without being obfuscated. What is the best practice? While Mohammed asks a very similar question, slightly more specific, asking how does automation ensure customer data is protected and scrambled? The data we're using in production need to be PCI DSS compliant and cannot be shared. We cannot make production copy for testing, which I would assume is fairly common, especially when you're using real life consumer data to test or the data that you already have kind of right there in the system to test the system.
Right, so very good points. When you have things, especially when you have compartmentalized data or private information, these aren't things that you can just have anyone able to pull data across. And some of the best practice answers are having, well, there's a couple of ways you can do it with the databases. You can have an entirely separate database. But when you do that, you need a few database practices, such as you only ever have an add-on policy when it comes to fields in the database. You never remove and you never change. You only add a new one. So that what you're not doing with database evolution is creating the possibility that something elsewhere that was looking at that old database field is now not going to work because that's changed, that's gone, that's missing or something. But the new code is now going to talk to this new field. So this is some of the ways in which you can prevent database misalignment. But when it comes to the raw data underneath, then you can either have a scrambling process, but that's often very overhead intensive. That's going to take a lot of computing power for a lot of systems with a large amount of data. You can go with a pre-scrambled sample data that is repeated with what we call there's a phrase, procedurally generated data is the phrase I'm looking for. Procedurally generated data is data that fits the same paradigm of the data that you're working with, but it's been created specifically for this purpose. Now, you might be able to get away with procedurally generated data that's fake data that exists in exactly the same format that it's going to exist in the real database, but it's not the same data. So there's no sensitivity associated with it. But the most important part of that is having enough database structural hygiene to know that if anything structurally changes in the core database, that your new database has the same structure. So what you can do is you can have a database copy, have a wipe, have a repopulate with procedurally generated data. Now, every time we start to talk about these things, we are adding costs and tools that need to do these certain tasks. But organizations that deal with highly sensitive data are already investing in ways to make sure that that data is protected and secure. And there's already an effort to make sure that the data is looked after in the right way. Now, if they also want to be developing software that looks at that data, then having systems and tools that will help create copies of that desensitized data is a necessary investment. Because your alternative is to put the entire development team at risk, where they might otherwise be working on an out-of-date system, an out-of-date environment, an out-of-date database structure. And if they are, and they write some code, could that code potentially cause a security problem? And is it therefore not perhaps counterproductive to say, well, we're going to be so careful about security that we're not going to let the dev team have what they need because they might see something they shouldn't see, when actually what we might be doing is creating a loophole where the dev team inadvertently create a security vulnerability. So there's a couple of different arguments that work together there that play into, here's some reasons why you still need to take care of your data, but there's always going to be an answer. It's usually just a bit more work and a bit more money.
Great. That's that's fantastic to know. Thank you. And I suppose a good sort of follow-up for this as well is Harish has asked about security testing. So I suppose I would like to follow that up as well with, would you use the same kind of structure or the same sort of flow-based process with the different kinds of testing that you do for your security testing? Is this model applicable to all sorts of different tests as well?
Absolutely. And look, in situations, there's no such thing anymore as software that doesn't have a security KPI or requirement in some way. And so this is an integrated part of what the developers do need to deal with, and how they deal with it, what they have to do, what are their requirements, what are their critical success factors regarding this. That's going to be decided by the organization, by the organization's governance program, which then creates the info security rules of how these things work. And when the testing is done, one of the things that the developers will have to be testing is the security elements of what they're doing. This is another benefit of the automated testing, because you can have certain scripts that are security-based where you can run those 1,000 times. Now, you can also have a situation if you have dedicated people that are specifically focused on security, they might have their own testing scripts. And it might be a dual testing scenario where the developers are saying, well, I'm going to run the scripts that I wrote this morning to test the code that I wrote this morning, and I'm going to run these pre-made security threat-based script tests that are going to say, now I'm going to run these that I have to run as well. And then the outputs from those is something that the security professionals, security team, they might be auditing that. They might be reviewing that on a daily basis. Part of what they do might be saying, well, it's going to look at all the things that the developers did with the automated testing on security and threats and see if anything popped out. And if something does pop out of that, then we'll talk to that developer and say, hey, what happened with this? Did that get solved? Are you aware of this? What's happening with this part? So you're still creating a synergy between the different teams, and you're still making it happen in a single day.
Great, fantastic. And I think maybe one more for this section, and then we can move on in your slides. And this is purely, please indulge me, I am just fascinated by this because I don't know anything about it. But Greg has asked, just wondering if any aspect of chaos engineering comes into automated testing. I don't know much about it, nor do I, Greg, but I gather it's the new kid on the block in terms of real world system testing.
So I'm not as familiar with the details of chaos engineering, and I will be by next week. So I'll give a more complete answer to this question then, because I'm fascinated by it as well. But what I understand is that part of the idea behind chaos testing is that you need to test for things you didn't think of. And that's a hard thing to do. You're testing for the random, you're testing for the unexpected. Chaos engineering is like, well, chaos theory, well, there's a few interesting things about the chaos theory and the law of dynamics, thermodynamics. But when you look at chaos engineering, my understanding is that where it compares to DevOps is that the more heads you have in a particular problem, the more random you can test, the more things you can unexpectedly try, the more you are a step ahead of not being caught out by that thing that you didn't know. And so the more complexity we have with our computer systems as we go through, year by year, the more the unexpected things are going to pop up and crush us. Even the biggest, most well-funded, most smoothest running organizations have major outages and problems. And quite often it's something that no one would have thought of at the time. Now, there's two things that come into that. One is, well, if you have an extremely rapid response system, if you have a flow that lets you fix that immediately, then it doesn't necessarily matter quite as much exactly what happens and what the problem is. You've got a method of dealing with it in an extremely short period of time. But the more automated testing and the more wild and crazy you can make your automated testing, then the easier you're going to be able to find those really random, chaotic things that could happen. Those 1 in a million confluence of variables that happens to come together and trigger something bizarre. And human testing is a lot less likely to spot that and configure that. But if you have a range of testing that says, okay, I've got these variables, and these variables. Now let's run every possible combination from 0 to a squillion in all of those variables and just see if something pops out. And suddenly you get this report that spits out a sine wave that says, well, if you do everything just right, this weird thing happens. Well, automated testing will help you find that.
Great, thank you very much. And just on that, I do really enjoy the comment that's just been made in the chat saying, chaos testing, just give it to a customer to test. They will find a way to use your software in ways that you never thought about. And I just thought that was quite amusing. Thank you, Jasper. I can't
wonderful
imagine that is anything but completely accurate.
Absolutely. Maybe not the greatest policy, but in practical terms, certainly successful. Yes, it's like a friend of mine that, you know, if they've got a system somewhere and they don't know who's using it, they just turn it off and wait to see who complains, right? I know many people that have used that method of finding out who's using a system.
That is brilliant in its simplicity, actually.
That's
fantastic. I love that.
It is. Yeah, yeah. It's an investigative outage. So we've talked about alignment between dev and production. We've talked about automated testing and the importance of testing. I want to talk for a bit about continuous integration. Now, what I'm talking about here, before I get there, I'm talking about integrating the new bits of code that are being created into what would be, should be, your copy of the entire production system that it's meant to work in. So we're integrating any new bit of code into what will be the full live everything. And there's some analogies that are used that are kind of interesting and kind of useful, so we'll talk about them. There's the idea of the trunk. And the trunk is really just the everything. It's the amalgam of all the code working together. It's your test environment. It's your development version of what's in production right now. Now, you might have already added some code over the last few days, week, however long. But I mean, you've added some stuff and you've integrated it. And it's got more in it than the current live production has got. But we call it a trunk because you've also got work being done on branches. So you've got some developers that are working on their desktop, on their workstation. They're working on their piece for a while at least, you know, for a few hours a day, however long. And then at some point, they're going to have to make their little piece work with the everything else. So that's the branches versus the trunk. And during the morning, during the day, you can have a lot of developers working on various branches, but at some point, they're all going to have to come back together and play nice in the same environment, which is your testing environment, your perfect copy of what's in production. That's the integration. And we all know, we've all been there, where you can have perfectly working code that's been unit tested to death, works fantastic, right up until you put it alongside and into something else, and it bumps into some other thing. You've referenced the wrong or same thing that someone else has. Some other thing has actually put a 0 in that field when your code didn't allow for a 0 in that field. Stuff like that. There's all sorts of things that happen in the integration. So we know integration needs to happen. We know it's an important part. DevOps says you do it every single day. So what it means is you're not writing code for a week. Even if you're doing the fantastic code in the morning, write my scripts for testing, test it over lunch, test it in the afternoon, by the end of the day, perfectly working code. Tomorrow I'm going to write some more. No. The next thing we're going to do is integrate that code with the master. That's the DevOps method. Because exactly the same reasons that we talked about, you test contiguously. You immediately test after you create because that's more efficient. That's more effective. That's when it's easiest. And we're all about easy because easy is less wastage. So in the DevOps environment, we're saying we're going to integrate the code we're writing immediately after we've tested it because that's the best time to get it right. And that is intended by DevOps to be an absolute and direct counter to where technical debt often comes from. A lot of technical debt comes from the problems and changes, the workarounds that get put into the integration process. Because when we get to the point of integrating, you can either go back and rewrite that bit of code successfully, correctly, get your head back in it and totally redo it so that it works correctly. Or you can shoehorn it into place by adding a couple of lines here or there and doing something quick and dirty that makes it work. And every time we do that is technical debt, because sometime later, someone's going to come and look at this for some other reason, and they're not going to understand the extra stuff that's been tacked on and why does it work that way, because it doesn't make immediate sense. DevOps is saying, don't bring the technical debt unnecessarily, because that's wastage, that's inefficient, that's not going to help us push things out tomorrow. So this leads to a mantra that DevOps is telling us, saying, make sure that your test environment, it's actually, you have a staging environment. It's a place where you have a fully tested, integrated working version, a copy of production with your new code added in, integrated. So all the stuff that you worked on last week has all been incrementally integrated so that tomorrow that could become the new production. That could become live and be the new standard that we're all working to, the new production system. Any day that you want to do that, you can do that. Because every single day you've made sure that that box, that system, that stuff is tested, integrated, working smooth, ready to go at any time. Now, for people who aren't familiar, aren't used to the DevOps paradigm, that can be a bit of a shock. That idea, like, what? You mean any day? Well, if you think about the big organizations that use DevOps extensively, that push code every single day, that's why they're able to do it. Because everything they build is immediately tested and immediately integrated so that it can immediately go live if it's ready, if it passes the tests. So some of the practicalities around this, right? Some of you are thinking, yeah, but integration's hard. Well, it's harder the longer we leave it. And it's harder in a wasteful way. And we know that DevOps hates waste. So what we have as a process in DevOps is we say, well, if we hit some big problems with integration, it's all hands on. It's called swarming. The development swarms on the problem and everyone gets involved to fix it. And the reason I say everyone is because, well, it's anyone who might have code in there already. Right? I mean, if you've never put a bit of code in there in this particular version, maybe you're less likely to get involved in that. But then maybe you put some code in there last week and that's what's causing the issue. And we need to find that. So it's a typical point where all other development could stop for everyone who's relevant to solving the problem. That's where the swarming comes about. Because nothing is more important in the DevOps paradigm than having that green staging area ready to go blue and live tomorrow. And if it can't, then we're going to stop all development. So you have this thing called an and-on chord. This was part of what was invented by or used by Toyota. The and-on chord was a production line, factory car production line system where there's this cord that literally hangs and loops from station to station all the way down the manufacturing line. And anyone working on any station could pull the cord. And what would happen is that supervisors and everyone would rush to see what that problem was. And even if they thought there might be a problem, they were welcome and encouraged to pull that cord. People would rush to the site, the situation. And if it wasn't immediately solved, the entire assembly line could be brought to a halt by one person who knew and saw that there was a problem until it got fixed. And then it was everyone that needed to be there was there to solve and fix that problem so that the assembly line could resume as quickly as possible. But it stopped because the worst thing we could do is let it go on and let the problem compound. So DevOps is saying, absolutely never, ever let a problem compound. This is what we've talked about with this contiguous testing idea. You never let something get worse than it absolutely has to be. So the idea of the and-on chord is saying, well, anyone can say just like problem, we can't go live with this system tomorrow, stop development. Now, obviously there's other workarounds of saying, well, let's just pull out that integration code that can't go in there today. Go back and do some more work on that tomorrow. That might be the answer. Or you might have reasons why you really want this to go out and push out tomorrow. So it depends on what the particular problem is. But this boils down to the idea of the daily committing of code to the master, to the trunk, to the new version of what could become production any day. So you don't get any backlog of complex issues. You don't have this thing where you've got this huge list of code that needs to be integrated, and the whole integration process is this massive headache that takes days or weeks to get done. And you probably still miss stuff. Because by the end of however long you go through this integration process, it's frustrating, it's draining, it's difficult, and it's far more likely to let something slip through. But little tiny pieces of work that are pulled into a person's queue, worked on, tested, integrated daily, means that the risk of something getting too big is really small. This brings us to the final point, area of discussion for tonight, which is the deployment. So we're going through the sequence of events. We've talked about aligning test environments. We've talked about having automated testing. We've talked about continuous integration of what we've built. The question of deployment, if you're going to have something that's always green as a staging area with your core trunk of code ready to go at any point, and if that code, it's already been tested, it's been through some degree of quality assurance, and we know it's on an exact version of what production is. It's so exact that it could become production tomorrow. And yes, as we talked before, that might mean you're now talking to a different database. When you go live, part of the cutover is you say, well, we're going to talk to this other database. Now, you might also have a point at that stage where you have a duplicate of the real database that it gets pointed to as part of the test phase before cutover. Maybe not, depends on your situation. But how do you get code? How do you deploy code when there's so many different reasons to deploy code? One of the first things you need to do is separate a release from a deployment. Now, DevOps uses this terminology to say, well, what's a release versus what's a deployment? A major release is something that has influences outside of the technical environment. You know, it's something where there's some sort of marketing promotion, there's some sort of commitment to the customer. There might be invoicing attached to it. There might be announcements. There might be training going on for users. There's something that changes the value of this system for either the building organization or the using organization. And we call that a release because it's going to involve people outside of the DevOps environment, and it's going to be less often. It's going to be significant. You might have versions, significant version deployment, where a bunch of features gets put together, may be described as capability, which requires a group of features working together within a product. You might have it as a big enough that some things get changed, right? Where the patch notes become a little bit bigger, where the updated information is more significant. People need to know about more of this stuff. Minor deployments are perhaps any small bit of code, small bit of feature that gets added. You know, you've added an extra button, you've added an extra thing on your drop-down menu, you've added an extra thing that it can do. And then you get the hot fix, which is not necessarily adding something new, but which is fixing, correcting, or improving something that was already there, but now works a bit better, or maybe just works at all. Now, these don't have to be the way you do it. There's freedom here to describe and define what's appropriate for your business, your organization. But the first and most important thing is that anything that's externally driven needs to be separated from and giving you the opportunity to still have your own internal deployments. Because releases often have to happen at a time of day when the users aren't using it, out of hours perhaps. It's not feasible for a DevOps team to be constantly working out of hours for every single deployment. So they need a way to be able to deploy things that don't have that much fanfare and can be deployed within their normal operating hours. So types of deployment, how do we do that? Some examples that I can talk through at the moment. These are just some examples. There are many other ways of doing this. And I've kind of alluded to this already. The idea of the blue-green deployment. where the live production environment that everyone's using right now, that's the blue environment. And the green is your staging environment. It's your test environment. It's the place where everything has been integrated and tested as working in an integrated fashion. That's the thing that green is always ready to be blue at any moment. And when it does become blue and it passes those tests and we're not rolling back, then the blue environment becomes the new green. And that's where we start adding our new code to that for the next deployment. So that's the blue-green deployment methodology. A scaled methodology is where we might say, well, we're going to deploy it, but only to a limited number of users or a limited number of systems. We're going to start small. We're going to mitigate, limit the amount of impact that it could have, and we're going to assess the results of that first. We might even do a canary deployment, which is where we might just launch something to 1%. You know, similar to the canary in the mine idea. Well, if your 1% rollout falls down horribly, you're not going to roll out the remaining 99%, right? You're going to scale it back and you're going to fix it and try again for another deployment. You also have other things that you could tack on to this. You could have additional, third party is not the right phrase, but you can have additional secondary effects monitoring. Let's say, for example, you've got a system and you're deploying some things to users and users are accessing it online, and you have some monitoring that says, well, if we get more than a 20% drop in user activity within this next 20 minutes, we immediately roll back. We don't even know if there's a problem, but this other reporting is automatically going to say, this is an unexpected set of outputs unrelated to anything that we know what's going on in the code, but we don't like it. System just rolls it back automatically, tosses it back into the green and say, yeah, figure this out. Why did this happen? And then we try again. You've got other things that are application-based, feature toggles. You can deploy something in the code, get it out there, but then you can say, well, only a certain number of people can use it, and they can only use a certain amount of features. Now, feature toggles have been available for a long, long time. You know, back when they used to, the software industry started distributing software online, and you get the beta release where you get the feature crippled release. Until you put in the license code, half the features don't work. I mean, we've all experienced those pieces of software. So we're familiar with that idea, but you can do that on a live system and say, well, we're going to put it out there. It's going to be there. And maybe we're going to test it, or a few people will get the feature. And if that really works out, then everyone will get the feature. Windows does that a lot. A lot of operating systems do it. Office does that. That lets you do dark launches, which is where an entirely new and additional piece of functionality is actually live in the system right now. It's just that most people can't see it. Your testers can see it. Your test users can see it. Your guinea pigs can. The customers that are going to forgive you, maybe they'll get access to it. And when all that's working okay, then we'll start opening it up to more and more users. Now, these are just examples of ways that we can, in practical terms, deploy things in a way that gives us a degree of security, an opportunity to roll back, but also it allows us to deploy different things in different ways. We can put little things out every day. We can put big things out every week. And we can put major releases out maybe monthly or something. It really depends on our organization. So there's no rules about how we structure it. The only rule is that you don't let your DevOps deployments be totally guided by customer interaction. These are environmentally based. These first four here is based on the environment, and you're using the environment to manage the deployment. And these are application based. So in these cases, you're using the application to control the degree of the deployment. So you end up with continuous deployment. That means that your value stream is continuously delivering something of value, perhaps every day. All the way along the stream, constantly something new is becoming available. It means that your development teams and your ops teams are regularly, daily, practicing the process of working together to get things launched. Because remember the other system where ops live in an ops world, in an ops mindset, and they do their thing every day, and developers come along from time to time and, utterly ruin the world for ops with their new things. This means that everyone's on this every single day, and the ability to learn and work together and function together is paramount. So they do. It means that by putting out something really small on a regular basis, it's a lot easier to have a small response to it. It's easier to roll a small thing back. If you put out a massive feature release with tons of features and something goes wrong, you might have to roll back everything. But with a graduated response, graduated release, you're only dealing with small things, small risks every time. But it means your lead times plummet, like really plummet compared to other methods. So we end up with flow, maximum efficiency with minimum waste. Now I've got one more slide, and then I think we'll grab remaining questions. So if you have any more, I'm going to round it up. And then actually what I'm going to do is go through this, and then we'll have another look at the poll and see if we've been able to find some things that are going to answer those questions, the original poll. So all the things we talked about tonight, we've talked about continuous testing on accurate environments. We've talked about automating it as much as possible for regular immediate feedback. We've talked about integrating that code with the master, the new master, on a daily basis. And we're talking about making sure that that master is ready to deploy on any given day and jumping on it if it's not. And that is our continuous delivery, not only of software, but a continuous delivery of value. Jack, I'm going to share this poll again.
Oh, sorry. I think we both
I've got it.
Share poll at the same time. And
Did
we've
you?
got it
Okay.
now. Yes, I think you clicked it before I had a chance to, and then I clicked stop sharing. So we're okay now.
Okay. So just quickly looking through these, dev team lacks the time, skills, and resources to get it done, to deliver reliable code. A lot of the time, executive and leadership doesn't understand enough about what it takes to deliver good code. DevOps is a framework that says this is what it takes. If you want the benefits of continuous value delivery, you need to invest in these certain things. So DevOps is a framework that says this is what you need. No excuses, no half-baked. This is how you want to do it if this is what you want. And if you want something that's halfway there, because that's what you can afford to pay for, then that's what you're going to get. But that means you don't put the unreasonable expectations on the team to say, deliver this in this time frame, and no, we're not going to give you the automated systems that'll let you do that. We talked about this second point, dev teams lacking a complete and accurate understanding test environment. In the DevOps environment, that's an absolute must-have. That's an unforgivable, can't do it any other way, figure it out, make it happen kind of scenario. External pressures, this is a lot to do with the fact that everyone wants the value. This is part of the release problem, right? So the external pressure from customers, from leadership, from finance, from everyone else is saying, yeah, get us some good stuff out there so the customers are happy. That's their perspective. Now, if we can separate out that from all the little incremental things that we can do small scale every day along the way, then those bigger things are not massive headaches anymore. They're just the last push of what we've been doing every day for the last few weeks. Ops lacks the chance to prepare. Well, if they're pushing every single day or every second day or whatever your schedule happens to be, then they're a lot more able to know what's required. They're working with them on a regular basis. Then ops struggling to find the time to fully support the dev and testing and QA. Well, if dev have their own automated system, if it's fully self-service, if devs can do a lot of that themselves, then that's not necessarily a problem that ops needs to solve. What ops needs to have is to facilitate the ability for the dev team to have what they need when they need it without interruption or intervention. And lastly, don't have a clear idea of exactly how production is configured. Well, if you're constantly pushing something out there, you're constantly finding what you don't know about your own system. Those gaps in your knowledge will quickly be found and revealed and solved. And to some extent, they don't matter because you're going to have some of that anyway. And by doing it small scale every day, you're dealing with that consequence and keeping it very small. You're not dealing with it on a big bang method that says, here's what we've been working on for the last 3 months. It's going to go live tomorrow. Oh my God, I hope we haven't overlooked something. Because we have. And what does that mean for us? It's the complete opposite of that paradigm. Now, if we haven't answered your question on any of that, now's the time to throw it up in the questions box, and we'll see if we can tackle it as we wrap up.
Yes, fantastic. We will have another couple of minutes for people to put their questions in, and then we will close the Q&A. So last chance, really briefly, while you think of any questions to do that, just before we go to the Q&A, remember that all of this information is going to be available on learn.itmasters.edu.au for everybody, as is the recording from last week and all of the additional course materials. That is also where the forums are located. Has there been very much discussion in the forums so far, Brenton?
A little bit.
Subject? Okay.
Yeah, no, there's been a little bit, but people haven't been as feisty as I expected. I was thinking that people might be more boisterous with sharing their thoughts and opinions on stuff. So maybe I can start a few provocative thoughts for people to share their thoughts on.
Yeah. All right. I'm excited to see Brenton getting spicy in the forums with all of the questions in, or asking a couple of questions in there, throwing some cats among the pigeons. If you too would like to see Brenton being spicy, feel free to get on board at learn.itmasters.edu.au. And also, if you are interested in the materials that we've been going through here and you're keen to check out some more of our free short courses, we've got just on the screen currently a list of some others that we have recently provided. We've also got a number of our actual university subjects, which the source material for the which all of the content from the short courses is taken from quite directly in many cases. And if you're interested in doing those full-length subjects, they are available in our postgraduate courses. So those are master's degrees, one graduate diploma, and graduate certificates for people. We've got university entrance pathways for people who don't have a traditional postgraduate kind of entry level background, but if you do have equivalent workplace or industry certification type experience, feel free to click through to the link, which I believe Kit is going to drop in the chat now, which is the eligibility assessment link. And I will give you a call, or my esteemed colleague Anna will give you a call to chat about your eligibility for study or for course credit or for scholarships and things. If you are Australian based and an Australian citizen, we also have some great scholarship opportunities that are available currently, particularly through the ADF, the Australian Defence Force, which has a Cyber Gap scholarship, which is currently available. And there is more information available about that on our website as well. So with that said, we will be closing the Q&A now. So technically, you are still able to put questions in, but if you put any further in from now, they will not be answered. So we've got a few questions here.
Do we have some that are contextually aligned that we can tackle together?
Yeah, I was going to say, well, we've got a couple of quite quick ones on some of the more recent questions. So Gary asks if the blue and green source code is exactly the same.
No, the blue, just before deployment, the blue is the code that's been running for a day, a few days, however long it's been running. And the green is exactly that, plus what you've added since, and you now want that to go live. So everything else in the blue and green is identical, except the green now has this new stuff that you've added and changed in however long it's been, a day, a few days, whatever it is. But everything else other than that is, yes, exactly the same.
Sorry, I just forgot I was on mute. Neville has assumed that a mix of the deployment types is okay. Is that an accurate assumption from Neville?
Yes, I look, these are guides when it comes to this sort of thing. This is not the idea is you choose and you figure it out and you work out what works for you, your systems, your people, your environment, your customers. And a mix of production types is exactly fine. You might have days of the week where certain things happen, or you might have some things that happen once a day, something happen once a week, etc. Whatever works for you. But the point is, make those decisions proactively and break them up in a way that works. And don't get caught up in the waiting until everyone else is ready. You do it as soon as you can when you're ready.
Great. I think that actually leads quite well into several of the other questions, because I think one thing that I've certainly picked up over this week and last week's sessions is that a lot of this is about guidelines. It's about frameworks and kind of, giving people a bit of a template to put things into that fits their actual current situation. Would you say that that's accurate?
Yes, there are
yeah.
some hard rules of what you're aiming for, but how you get there, very flexible.
Yeah, that's definitely, that's coming across for me. So I suppose, Greg has asked, what about code for features that are complex and take multiple days to create? And this, I would assume, is about the testing, when you would run which kinds of tests. Does daily integration require those to be deployed partially built, perhaps with feature flags to prevent the partially built feature being available to end users? Is that question.
Okay, so in that situation, you might have a branch that doesn't go in at the end of every single day. You might have a branch that comes in several days later. And in between, the assumption is that there's other developers that are working on other things, and small things that are finished within a day, they are put in that day, so that people start work on Monday, and by Monday afternoon, they do their integration, and Tuesday, if they want to, they can go live with that. But Greg's working on something else that's going to take several days. Greg's not ready to integrate until Thursday. Well, when Thursday comes along, people have already integrated stuff Monday, Tuesday, Wednesday. Now, Greg's got the challenge of saying, okay, have I built for the version that I thought I'm building for? Well, automated environment means that I can just pull another copy from Wednesday's green environment and retest my stuff that I've been diligently working on for 4 days. Yeah, okay, that's working, that's testing. Then I let a few other people know that this is a slightly bigger branch that we're bringing in. And so we might have a few more people on hand on Thursday afternoon as we integrate Greg's code that he's been working on for 4 days. So absolutely, you can do that. You can accommodate that. The paradigm is that what everyone else is doing, DevOps is saying as a team, the thing's got to be green every day. And if that means that stuff, it might have meant that someone who thought they had their stuff ready to go in and integrate on Tuesday, it wasn't. Something wasn't right. They've got to come back on Wednesday and maybe fix it up and try and integrate it again on Wednesday or Thursday. All that stuff is normal and, yes, fully accommodated. It's not a rule that says you can't do that. It's a rule that says if on any given day you can't get this thing ready to go, then you need to react to that.
Great. Yeah, absolutely. So it's really, it's just sort of about the vibes, and it's about the situation in which you find yourself. If you'll forgive me for saying it's literally just vibes. Another one I would say is kind of similar, along fairly similar lines. Gary, a different Gary, has asked, where does user acceptance testing come into it, particularly in continuous delivery?
So user acceptance testing is generally coming from the perspective of the functional testing. So user acceptance is the human perspective of saying, does this do collectively what I want it to do? So that's very much the user story perspective that says a customer, a user had an idea of capability and functionality that they needed, where the technology's got to do something that helps what they do in the real world or in some other capacity. And so that kind of acceptance testing is saying, well, yes, this does what I asked it to do. And that's a test, not just of, does it work? Is it integrated? But was the original interpretation of the requirement correct? So what was the user story correctly interpreted? Now, there is intended to be, through the regular feedback processes with things like Scrum and stand-up and elements like product management, to make sure that a sufficient feedback loop occurs during the creation process of specific features that need user acceptance testing. So if we assume that some of that has happened, then user acceptance testing might also be a part of the integration process or the pre-integration process. You might say, well, I've done my unit testing. You wanted an extra button here, right, that does this, this, and this. That's what my requirements say. So I'm now going to do the unit testing. I think it works. But someone over there is the person that I'm going to say, right, I'm going to give you access to this test system, just this test system. Can you do some clicking of this and see if it does what you need it to do. And that might be something that gets put into the testing requirements because of the nature of the function and the feature. It depends where it's come from. Because what we haven't talked about is, where do all of these changes come from? Who creates them? Who thinks them up? Well, they come from so many different sources that it doesn't really matter to DevOps where they come from. But if they come from a customer and they need user acceptance testing, then there needs to be a feedback loop incorporated into the process. And that means that sometimes users need to be aware that this is how we work. And, I've got your request on Monday, I'm working on it on Tuesday, and I'm going to make it go live Wednesday. Can you be available? Now, typically in my experience, the answer is, you're going to do it in 3 days? Well, yeah, I'll be there. I'm absolutely going to be available because I'm used to waiting 3 weeks, if that, So there is usually an incentive to get the right people involved at the right time. But DevOps says, if that's what it takes, that's what you do.
Great, thank you.
Rakesh had a similar question, right?
Yes. And if
Do you think
trunk
we've
is
answered
ready
that?
for prod, do we still need UAT? Well, I mean,
Maybe. Yeah.
Yeah, I suppose it's, once again, it's the vibe, isn't it? Is the vibe that you need, is the situation in which you find yourself one in which that's going to be crucial to your product or not?
It's, how do you design your testing regime? And it's going to be different for each release, perhaps. If you have a large amount of user requested features going in, then you actually might need user acceptance testing. And that's where you might do the app-based feature lock plan, where you release features only to certain users and make sure that they work, and that's your test case. And if that's working, then you unlock the features more broadly. And that's a way of doing user acceptance testing in a controlled manner. But it might be that the dev team is already working on something else because it's the next day. They can come back and fix it if they need to. But absolutely, it's not a way of saying you don't need user acceptance testing because everything's automated. You decide what testing regime you need, and you bring it in at the appropriate moment.
Great. Okay. Now we've got a few more of our general kind of questions here.
Yep.
I suppose this one here, fairly straightforward, yes or no kind of thing, just looking at the time. Juhi has asked a little while back, are there organizations out there who combine bots for the purposes of functional testing automation?
Yes, I definitely. I think that bots and simulators are a growing tool for, and also for testing unusual things. Humans are predictable. And although we like to think humans are predictable and users are predictable, and we think, users are going to do this, this, and this. But as anyone who's writing software knows, especially in the gaming industry, gamers will find a way to do something with your game that you never imagined that they would do. And things like that mean that using highly sophisticated and even slightly random and chaotic bots that can do a lot of different things as part of your testing, often quite valuable. And I think those things are growing in sophistication on an ongoing basis. And when you look at the host and cloud computing world, the industry, you're finding more and more AI-driven and self-learning bots that are actually able to figure out and try new things based on what they've tried before.
Fantastic. And finally, Chris has asked at the top of the session, and I think this is still a fairly relevant question. As an IT service manager who is keen to see more DevOps mindset applied to our services, how do I convince management that it's worth the journey? And I would personally like to suggest an answer to that, which is get them to watch the recordings of this short course, because I think that would be very convincing. You've made a fantastic argument for it throughout these two sessions.
So thank you. I hope that's a useful answer. But to add something perhaps more specific for Chris, the short answer I have is case studies. Case studies, case studies, case studies. Don't take my word for it. There are tremendous examples of absolutely staggering improvements in productivity and value output that modern organizations have been able to achieve by changing to not even all, just some of the aspects of what DevOps is trying to do. And if that sort of change and outcome is possible for those organizations, what does that mean for your organization? And that's something that you and your management need to think about and understand. But it's potentially so significant that it's quite difficult to believe it unless you can listen to someone who said, yeah, this is what I did in my organization. And there are some case studies in the book I've suggested. There are many others out there, but that's a place where I would suggest you start, because outside of that, everything's going to be contingent on how you work and how can you actually, your organization, increase value. So it's then going to get specific. I did notice another point before, Jack, about someone asking about scope creep. And
yes, I did delete that. I'm so sorry. We are just about to run over time, but feel free to drop in a couple of tidbits there for us.
I just want to make the point that if you're writing some code in the morning, testing it in the afternoon, pushing it out tomorrow, there's not a lot of time in there for someone to come along and say, oh, hang on, I want you to change what I asked you to do yesterday. Now, if you've got a scope of work that's got a lead time of weeks, there's ample opportunity for people to come in and say, no, I want it different now. But with lead times brought down to days, what's going to happen more often is that you do your thing and they say, oh, that's how it works. Oh, no, can I have it a bit differently now? Yeah, sure. How about by tomorrow? That's the idea of what DevOps is trying to do, because getting those incremental improvements, that's the empirical understanding. That's what Agile has started from. That's great from DevOps' point of view, because you're incrementally improving the value to the customer and what they want as they discover it, and on a really short lead time. So there's no such thing as scope creep, because every new request, every evolving request is an increase in value to the users and the customers. And when that happens on a daily basis, then all you're doing is just delivering more value every day. And yes, you're probably not going to get a lot of scope creep between 9 a.m. and 11 p.m. or 11 a.m. That problem tends to go away.
I was going to say, please don't work from 9 a.m. to 11 p.m., but there are a lot of software developers on this, so that may fall on deaf ears. Well, that I would say that brings us to the end.
Excellent.
Brilliant.
Excellent.
Thank you very much, Brenton, for another fantastic session. Once again, the recording of this, as well as all of the additional materials and those forums in which Brenton will be getting spicy this week. So hang out on the forums if you would like to see some of that. Can be found at learn.itmasters.edu.au. If you're interested in further study with IT Masters and Charles Sturt University, you can visit our website, itmasters.edu.au, fill out an eligibility form. We will be back here again next week, same time, same place, at 7:30 p.m. Australian Eastern Standard Time for the third of our 4-session short course on DevOps with everybody. And once again, thank you so much, Brenton, for such an informative and instructive session. Thank you to Kit for doing tech support for us. And thank you to everyone who has attended. We really, really appreciate it.
Yes, thank you. Thank you, Jack. Thank you, Kit, for all of your work behind the scenes. And thank you, everyone, for your questions, for your comments, for your contributions along the way. It's a tremendous pleasure. And hopefully we'll be able to bring something just as exciting next week. Until then, that's all from me for now. Thank you and good night.
Thank you, everybody.